Hello everyone, welcome back to the workshop. I hope that you're all well. This video we are back on with the D7 Bantam. It's a swinging arm video and we are going to remove the old bushes, fit the new bushes and get the swinging arm back on the bike. There's a little bit of press work, a little bit of lathe work, and apprentice Edward makes another appearance. He comes in and helps me with one of the trickier jobs, which is great. Always fantastic to have my boys in the workshop with me. We do hit a bit of a snag towards the end, which you will see, and I warn you now, I do waffle on about materials a little bit, but then it is me, so you can kind of expect that. I hope that you enjoyed the video, so let's get on, do some work. Right, welcome to Retro Circus. Today's star attraction is Dino the Juggler, and I'm going to try and keep all this lot in line while I press out the swinging arm bearings. And I've got the special tool that I made in here. I've got an 1.1/8" socket down here to catch the bush and to support the bearing flange, and a socket extension going through the middle. And we're doing it like this because, you know, if we try to press from the top, this being an open H sort of format, then we'd absolutely distort the swinging arm at that end, I would think. So hopefully this won't take much force to go. Well, I'm going to get out of the way just in case. There we go. Not too bad. Not too big a bang, really. There's one. I think that's probably never been out of there. I imagine that's the original one. There we go. He took a bit of going, didn't he? But he went. Right, let's get the other one out. We'll do exactly the same again. Let me just back the jack off, which we've done. And do it all again. I was quite pleased with that, actually. Worked very well. So if you can hear a bit of background noise, the camera tripod is right above where the workshop heater is. So you may just be picking up the fan from the workshop heater, but hopefully it won't spoil your enjoyment. It's absolutely freezing here at the moment. It hasn't been above about -2 for a couple of weeks now. So yeah. Proper winter weather. I'm not happy with that. Let's just get that socket a little bit more lined up. I'm not happy with that at all. It's all a bit on the wonk. That's better, more natural. A bit more central. There we go, I think that'll work. it's wanting to wander about. Oh, that was just my big box of press tools at the bottom moving. There we go, that should work. There we go, liberated. Okay, well, it worked. Happy days. There's number 2. Again, I don't think that's ever been out, but you never know. You never know. Okie doke, we'll get the swinging arm cleaned up, get ready to put the new bushes back in. Okay, I'm just going to clean out the bores. If you want to know what I'm using, it's a gun cleaning brush, part of a gun cleaning kit in an electric drill, and because it's really stiff, can you see that? Really stiff nylon bristles, it doesn't do any damage to the metal at all, but it really cleans them lovely. If you've got any sort of bearing bores or anything like that that you want to clean without damaging them, these are ideal. And yeah, it's just spiral gun cleaning brush. You just you know, give it a bit of a going out and then wipe it out with a bit of your squirty oil and a bit of workshop wipe. It's perfect. Gets all the rust out, doesn't damage the metal, and is ideal for the job. So, just do this one. I don't know if I can keep you there. I might be able to. You'll be able to see it do its job. Can I get in there with you there? Maybe. That ought to do. I'll see if I can get the camera to look down there in a moment. They were pretty rusty in there. There we go. Let me see if I can get you to have a look down there. Excuse me manually operating the camera. I don't know if that's going to focus. Well, yeah, all the rust's come out. It's just clean metal now. So we should be good to put our new bushes in. Right, we're back again. We're going to put the new one in, or one of the new ones in, and I've warmed it up a little bit, just because I think the minimum amount of resistance we get, the better, really. Which one did I warm up? That one. So I doubt it'll make much difference. Oh, it's going in a bit easier. Starting easier, so that's definitely made a bit of difference. Okay, so put our rod in, and we'll get the jack in position. I'm hoping that you've seen all this well. Let's just see if we can get this a bit more square before we start putting force onto it. No, that's not going to play. I think I need something a bit chunkier than this socket extension, perhaps. So one more go, if it doesn't work. If it doesn't work, it doesn't work. We'll get something else. Okay, so that's starting off reasonably square. Might help if the swinging arm is out here, so I can handle it a little bit better. Oh, I think that's better. I think it's just where I had the swinging arm. I think I was just in a bit of an awkward place. Put a little bit of grease around the outside surface of the bush. You notice I've got no socket underneath now because I want to come to a dead stop. Which is where we are. Okie dokie. Success! Let me get you a view of that. There we go. A little bit of grease pushed through. And that's one done. And I shall do the other one off camera because you've already seen it. So get the other one in and then we'll see what we're like for dimensions. Right, well, we have our swinging arm up in the vise, and there's our two bushes that we just fitted over at the press. And I did find, I don't know if you can detect a slight hint of shininess right around this edge here. I did find that it raised up a little bit of a burr, and I just had to remove it. I used the edge of this needle file as an improvised scraper, and I just went in there and took it out. And it's nice and smooth now. You can run your finger around, so no problems there. But I'm really happy because I have had the pin fitted, and let me just show you. You'll recall that we used our guide tool, which was a good close fit, to try to prevent the bushes from closing up, and I warmed the housings up slightly before I pressed them in, the flanges, and that's a really nice fit in there. And then we get over here, and with just light thumb pressure, it's in. And I can rotate that by hand. There's a bit of drag on it, which is absolutely fine. If I was going to ream it, that would be the fit I would be going for. I wouldn't be going for anything slacker than that, because that will work perfectly well, particularly when it's greased up. You want a little bit of drag, tiny little bit of drag, and yeah, I'm really happy with it. That's absolutely spot on. So let me just press it out, and as you can see, I just use my finger to press it out, so it isn't a tight fit or anything like that. But yeah, I'm really happy. So we don't have to do anything else to that. And guess what I did? In anticipation, I actually did buy a reamer, and I said I wouldn't, didn't I? But this fella came up for £8 second hand, and once I cleaned all the swath that the previous user had left on it, this is what we're left with. It's a couple of edges on the blades, could probably do with a little tickle on the stone, but yeah, apart from that, it's like new. You could use that you could use that straight away and get away with it. Of course, you couldn't just whack this reamer through there, because, you know, the whole point is that you're reaming them concentrically. So the plan was to make a conical guide, a pilot, and if any of you remember kingpin reamers, if you've worked on old Morrises or Commer vans or anything like that, you'll know what I'm talking about. That was basically the plan, but I don't need it. However, I do have another swinging arm in here that needs to be done. I've no reason to use it, or I've nothing to use it on at the moment, but I'm going to do it anyway. So I'm going to make the kingpin reamer for our, the kingpin guide for our adjustable reamer. So that's a little project for the future, but at the moment we can get that swinging arm on once we've checked the end float against the frame. We can get the swinging arm on. So happy days, moving forward. Right then, lovely people, I've got you up on the parts washer, peering down at the back end of the bike, and what we're doing is checking the end float, or side float if you prefer, on the swinging arm. And as you can see, it's partially fitted. We've got the pin through the first, through the offside eye end into the offside part of the frame, sufficiently in to hold everything nice and square. We're hard up against this offside side of the frame lug, and that puts us on the centre line. And here we have a gap, and that gap is controlled by a thrust washer. And let me just get the caliper, because I've already been, nope, let me just drop it on the floor first. That's always the first sequence of events. Right, clean it a little bit. There we go. So I've already been measuring things, and we have got 65 thousandths on our thrust washer. And then I've got a feeler gauge stack here which measures 70 thousandths. And if I hold that, take a little bit of the weight off the swinging arm, make sure it's nice and square. I don't know if you can hear that. I'll try and exaggerate it a little bit. But it's what I would call a good feeler gauge fit. So if we put our 65 thousandths thrust washer back in there, we're going to have a gap like a donkey's yawn, aren't we? So that's no good. So next job is to make another thrust washer at 70 thousandths. So I'm going to go away and do that, and hopefully we'll get our swinging arm back in. Well, we found our sweet spot, parting off the thrust washer. That's 120 RPM. And this is a bit of S45 420, which is a martensitic stainless steel. You'll find this material quite a number of places, nuts, bolts and washers, anywhere really where you need good corrosion resistance, where your yield strength isn't so important, but you still want a reasonable yield strength, somewhere around the 450 to 500 megapascals. But the good thing about it, because it's martensitic, it's heat treatable, very much in the same way as a carbon steel would be. So if you do need to harden it up, you have those options. And I'm just parting off now, as you can see. I've put a quite, not overly generous, but reasonably generous chamfer on the edges with a file, and I didn't want to mess around changing the parting tool now that I'm in there. But yeah, we'll get it parted off and carry on with our job installing the swinging arm. There we go. We have liberated it. So I will get that cleaned up, and then we'll check it for dimensions. This being a metric lathe, I obviously had to convert my 70 thousandths into millimeters, and so we're probably a little bit over. Just for ease of using the travel dial, we're probably a little bit over. So we can always bring it back on the stone if we need to, but we'll see how we get on. Can you see that? I hope you can. I've just cleaned it up, and that's where we're at. So, are we going to live with that? Too right we are. Half a thou. Half a thou between friends. So we're not going to quibble, and that's going to be our shim. Our thrust washer, rather. So, whatever terminology you care to use. So, yeah, happy with that. Onwards and upwards. Right guys, we're getting ready to put our swinging arm back in, and I've just had a bit of a tidy up of the bench. It was looking like a disaster movie. Last weekend my eldest son and I fitted some oak shelves up in his bedroom, and that was a nice little project that we did together, but I left basically everything that we'd been using all over the bench, so it was hardly conducive. Anyway, I've got that tidied away now. There's our thrust washer. This material, the 420, it comes in at about 230, 240 I think on the Brunel scale for hardness. I've just given it a quick quench and temper back just to see if I could improve it. I've no means of testing it obviously in here. I know some of you guys have got pre-sip ovens and hardness testers and things in your workshops. I can hardly get in mine, so yeah, that would be a pipe dream to me really. But it won't take a file, so I'm estimating we might have improved it to maybe 270 or 280 or something like that. To be perfectly honest with you, I could probably have left it well alone, but I just thought I'd have a bit of a play with it and see what happened. Anyway, we're just about ready to go back together, and while I'm waffling on about materials, which I haven't done for a while, as I say, if you haven't got facilities to do hardening and things like that, a lot of the time you can select your materials, and with a little bit of compromise and a little bit of research, you can find stuff that will do the job for you. And I'm just going to waffle on a little bit longer about material choice. You might find it informative. I don't know, you might not, but anyway, bear with me. Right, we're looking at our old swinging arm pin, and I think we were right to replace it, don't you? It's had a bit of a life, and largely the defects are caused by corrosion, and we've had our perfect storm of a corrosion cell at the bush locations, the clearance caused by, the clearance of the bushes with the pin inside, dissimilar metals, and just enough room for a nice effective electrolyte layer with our rainwater and whatever's thrown up off the road, probably impurities and grit and things like that getting embedded into the soft material of the bush, and scoring the material and creating it's just the perfect environment for our corrosion to take hold and attack the metal. And yeah, definitely past its best. And if you watched my previous video when I removed this thing, I spoke about the potential of manufacturing one in the home workshop, and you know, particularly seeing as these things cost about £40 to buy, and I only know of one supplier in the UK that does them, and they're not always available. So making one seems like quite a good option. Now, one of my viewers, Chris, who is very knowledgeable about British bikes, and he's done a lot of maintenance and a lot of work on British bikes over the years, he commented and said, well, you know what, Dean, actually, when you think about making one of these things, £40 doesn't sound like a lot of money. And he's absolutely right. When you break this down into a series of processes, you've got sort of rough turning, you've got drilling and tapping, you've got milling for the grease pockets, you've got heat treatment, heat treatment, and you've got grinding back to final size. And if you've got all of the facilities to do that in your home workshop, if you're lucky enough to have all that, then not a problem. But if you don't, and you have to farm that out to somebody else, then yeah, your £40 suddenly seems like really good value. I don't have those facilities. No precip oven here, no cylindrical grinder, no hardness tester. So yeah, it would be, it would certainly be a challenge to perfectly replicate this pin in this workshop. However, I think that we can still do it, and I think we can do it by taking advantage of material selection and selecting a material that gives us the properties that we need without the processes that we'd have to go through. And such material does exist, you'll be pleased to know. Obviously everything is a compromise, but I think we can select a material that in some ways outperforms this original part. And I don't know what kind of steel this is, whether this is the original BSA part or whether this has been replaced at some point, but clearly it hasn't been greased very well, probably every time it changed owners, or maybe not even as often as that. So it's definitely suffered from a lack of lubrication. But I would say that the corrosion resisting properties of this metal probably fairly low. Yes, it's been hardened and ground, but unless we knew what the original base metal was, we can't really make an educated comment. But just looking at the corrosion attack, I would say that it's probably a high carbon steel with fairly low corrosion resisting properties. So let's have a talk about what we might use to replace it. Right, I've got the technical notebook out, and we're going to talk about this material. And let's think about the properties that we want. We want corrosion resistance. We want tensile strength, because obviously it's an axle. It's supporting the rear of the bike. It's got quite a lot of weight on it, and it probably takes quite a bit of shock loading as well. So some shock load resistance would be good. We want hardness, because we don't want it to wear away in the bushes after just a few miles, so we need a bit of hardness. Now, those are our parameters. What is our metal? And the one that is in my mind to use is used quite a lot in my industry, and that is 35 NC6. And you probably think, that's not a metal spec, what's he talking about? It is. That's what we call it, and that's because it is a French aviation standard. And that's no use to you guys at all, is it really? The good news is it has other designations, EN24 or 4340. And what is it? Well, it's a nickel, chromium, molybdenum steel. And it gives us all of these properties without needing any special treatment. So let's talk about some of the properties that we get. As supplied, it comes in T condition, and T condition gives us about 300 to 310 Brinell hardness. It gives us 850 to 1000 megapascals in tensile strength, and it's very machinable. It is tough, don't get me wrong, it is quite a tough material, but you can machine it. I've done it before using tip tooling, and my lathe would handle it. So, you know, most of the lathes that you've got out there in your workshops would also handle it. I think if you turned it between centres and you were careful with your sizes, you could manufacture with good surface finish a pin that would do the job. And I think that these strength and hardness characteristics, particularly if you consider we are going to lubricate, we're on top of our maintenance, we probably over maintain our bikes these days. You know, back when these bikes were used by people to get around, they were probably just used and abused, whereas we tend to keep on top of our maintenance. I don't think you're going to have a problem using that material, and obviously you won't grind it to a precise size like they did at the factory, but don't forget, we will machine our pin and then we will ream our bushes to suit our pin, so we can get around any slight discrepancies in size that way. But you know, I think we can hit sort of, I think they're 990 or something like that, or 980, I can't remember now. I think we can hit those numbers with the lathes that we've got, and yeah, that would be my answer. Now, this material is heat treatable, so if you do possess the facilities, you could buy it in the T condition, and you can heat treat it all the way up to what they call Z condition, and that gives you about 450 Brinell on the hardness, and takes you up to about 1550 megapascals on the tensile strength. As I say, it ticks the box for corrosion resistance. The chrome and the molybdenum help us with that. You know, between 850 and 1550 if you possess the heat treatment, but certainly a minimum of 850 megapascals on the tensile strength ticks the box there. It is good. It has good shock load characteristics, so it's not just going to fracture the first time you go over a bump. And we've already talked about minimum of 300 Brinell straight out of the box, so you know, reasonably hard from the get-go, which is what we need really. And I spoke about the aviation standard. This stuff is used in the aircraft industry quite extensively, and some of the stuff that we've used it for is undercarriage bushings and undercarriage pins, retraction pins and things like that. So my sort of final word on it really, if you like, is if you can land an aircraft on it, I'm pretty sure it will hold the back end up on your BSA Bantam or your Triumph or whatever it is you're working on. So EN24 or 4340, and I can buy that in the UK. I can get a 300mm length. I think it's an inch diameter. Curious mixture of imperial and metric, but there you go. I can get that for about £20, or 18 to £20. So we've got a good project to do, and we save ourselves probably 50% on the cost of a new one. So I hope that was informative and gave you a little bit of food for thought. Maybe not, but there we go. Waffle over, I promise you. Okay, let's get on. Okay, we are getting ready to fit our swinging arm. Let me just get you a better view. Apprentice Edward is holding the swinging arm and guiding the thrust washer. And we've greased up with our red and tacky grease. So everything is red and everything is tacky. I'm just going to put a little bit more on the pin just to guide it in. And then obviously we'll clean up the excess when we're done. But this is it, this is the moment. We're going to tap the pin in. I'm probably building it up into a bigger drama than it really is, but here we go. See how we get on. That's going through very nicely. It's just going to guide the thrust washer. If we come to a shuddering halt, it looks as though we picked up the washer. There we go, we're in. Right, moment of truth. Does it move up and down, Edward? Can you wiggle it up and down? You can wiggle it up and down. How does it feel? Let's have a feel. Can you let go a minute? 1 second. Oh yeah, that's like silk, isn't it? And the next thing is, grab a hold of it. Can you move it side to side? No, absolutely nothing at all, is there? Let's have a feel. Yeah, I think we've achieved our aim there, don't you? Right, you grab a hold of that. Next thing we'll do is we'll get our pivot bolts back in and get everything basically reassembled to how it was. So I shall get ready to do that, and the next time you join us we'll be putting our pivot bolts in and just reassembling generally. Right, we are looking at our swinging arm pivot pins, or swinging arm pivot bolts, and I have to tell you, we've reached a bit of an impasse, hit a bit of a snag, and largely of my own making, well, through my own negligence really. These two fellas have been enjoying an extended spa break at my exclusive parts washer resort, and they have been a little bit out of sight and out of mind. I've come to fish them out and clean them up so that we can get them on the bike, and obviously we have British Standard cycle threads here, but we don't have British Standard cycle threads in our new pin. And as soon as I fished them out and saw these threads, I thought, they're not going to be compatible. I've been working with the pin quite a bit, obviously. It's been, you know, in my hands quite a lot, and yeah, I immediately thought, well, they're not the same threads. And I assumed, wrongly, that the new pin would have the same threads as the old pin, but yeah, clearly not. I have measured them now, and quite disappointed to say that they're metric, and they're a 1.25mm thread, and it appears to be M12. Now, M12 is normally 1.75, but there is a metric series called Superfine, and that's what they are. So, yeah, we've ground to a bit of a halt. I think it would be too many steps backwards to pull the pin again and to try and get another one, or to go through the manufacturing process that I spoke about earlier. I just think now that we've got the back end of the bike pretty much together, we need to keep moving forward. So with that in mind, we're going to make some new bolts. I am a little bit disappointed. I didn't want to put metric threads in this bike. I wanted to keep it factory, but yeah, it's just going to have to be a compromise, I think, at this stage. But what we'll do is we will make hybrid bolts. So we'll keep the 9/16 AF flats. We will keep the 2BA grease fittings, although we'll get some new ones, new bolts, new grease fittings. and obviously this shoulder here, which corresponds with the frame components, we'll put this in, but we'll put our M12 1.25mm threads on, and we'll do it that way. That will be the compromise. So I'm going to have to go away and get the materials that I need to make these things, and so that's where we're going to leave the video. We didn't get to complete it this time around, but the next video hopefully will be making these bolts and getting the job somewhere near complete. So I just want to say thanks very much indeed for watching. It's very much appreciated. Thanks for all your positive comments. Please keep them coming. I really do enjoy reading them, and you know, as you heard earlier in this video, I get a lot from them. They get me thinking. I learn a lot. So yeah, please keep those comments coming. And to all my subscribers, all of you, guys that have been with me for a while, thanks very much for sticking with me. Guys that have come along recently, welcome. You're very welcome, and I hope that you enjoy the stuff we're going to do moving forward. If you're watching this and you're not subscribed, please consider doing so. We won't cost you a shilling, and we really do need you to get this channel growing. So yeah, please consider hitting the button. That's pretty much it, guys, and I shall see you on the next one. So take care of yourselves, and I'll see you soon.